So my name is Henrik Segesten, and I work as a technical architect at Volvo Cars. And I will present some what we have been using DATEX II for at Volvo Cars since a few years back. And then I will wrap up with some reflections and opinions that we have collected during the years on this usage. So this picture shown here is actually a promotional picture that is used for the services that we have mainly been using for data exchange with DATEX II. So the connected safety function has been a CITS service delivered with new Volvo Cars since 2016, and this is the main generator of data that is we are exchanging using DATEX II. And just as a brief summary, it consists since the start of two functions that are available to the customer. The first one is called Slippery Road Alert, and it consists of cars collaborating on detecting slippery roads and warning each other about these situations. And the second one is called Hazard Light Alert, and it's quite similar, but in this case we are detecting the usage of the hazard light in the car, and then we can warn drivers that are coming up from behind about this type of hazard. So almost since the start of when we launched these features in Northern Europe in 2016, we have been investigating and putting to use quite a few of this type of data in the data exchange. And early on, we tried to find if there was a standardized format that we can use to describe these type of situations, and luckily we quite early on found DATEX II. But we were less happy with using the SOAP, the SOAP exchange mechanism to exchange data with this, because we were actively looking for a more real-time way of exchanging these type of situations between cars and between our cars and other actors. So over the years, this picture sort of assembles the type of data exchanges that we have put into place, both for research needs, but as well for in production use. So what you can see is that on all of these links, except for the one down to the car, we are using DATEX II in different permutations, so different versions and different extensions for different use cases. But the main use is still as close to standard DATEX II as possible. But then we've added during the year what later become the C-words interface 2 that's used for hybrid communication pattern in C-words, which consists of the advanced message queuing protocol in QP with TLS authentication. So in the end, this is what the ecosystem looks like now. So we have connections to an interchange. An interchange is a concept that was invented during the Motorway 1 project, which is sort of a broker-like system where you can add and subscribe to different types of data, and you can also publish this data, and the broker handles the subscriptions for you. We've also utilized this pattern on point-to-point connections with other vehicle manufacturers, but we have also consumed data over the standard SOAP interface from road operators about roadworks warnings, for example. And down the communication link down to the car is mostly using proprietary protocols, since this is where we heavily try to optimize for size and speed. But we're also considering and have been using the standardized XE format as was shown in the previous presentations for this. So now we'll just do a brief overview of what the deployments that we have had using DATEX II has been over the years. So obviously the Nordic Way projects 1, 2, and now 3 has been a big driver for us in how we model the ecosystem when respect to data exchange. So here we have been using DATEX 2.3 from 2016 up to I think we still have some DATEX DATEX II version 2.3 deployments in production, and quite close to the standard specification, but with some level B extensions. And here we are exporting slippery road data, the hazard light warning data, and we are importing standard road data from the Swedish national access points. In later Nordic Way, especially Nordic Way 2 projects, have been trying out DATEX II version 3.0. It was quite new at the start of Nordic Way 2, but with great success been using this for also then exchanging data about roadworks, and we have been active parties in developing an extension that models emergency vehicle warnings in DATEX II version 3.0 within Nordic Way 2 projects. Then we're also participating in the Data for Road Safety collaboration, and here we are exporting our connected safety data, the hazard light alert and the slippery road alert, using the SRTI profile that was formulated with the help from this ecosystem. And I've also added the mappings here to the SRTI profiles. So we have been modeling the hazard light alert as an obstacle in road, since we are not, we do not know that this is actually broken down vehicle or an accident, but it could be a temporary use of the hazard light. The slippery road alert function is quite nicely modeled towards the temporary slippery road category in SRTI. Right, and then to the main part here, some reflections from us, how we have been using the DATEX II and what we have found good and perhaps where there are improvements. So we choose DATEX II in 2015 because it provided the most mature information model for this type of road safety data at that time. Then it was version 2.3, obviously, and we greatly appreciated the simplifications and the modularization that was done with the progression to version 3.0. That has improved the how we use DATEX II a lot. The navigable UML model, which then is the representation of the information model, is really the killer app for us. This is a really great tool to be able to find and understand the information model structures, and it's also a good tool to find where your own data model differs from the DATEX II model and how you need to adapt. So that is really appreciated that you provide that. Also the extension mechanism, we have been actively using extensions on the type of extensions a lot, and we've also been part of formulating new extension. And this mechanism is also one of the main arguments that we are pushing DATEX II with, is that it's extendable. I mean, it comes with a price of compatibility, of course. So you need to find a good way to manage what extensions are there. And then, of course, the website and the community around DATEX II with the profile directories and extension directories is a great help to manage your extensions and profiles. We have also tried the different types of encodings, mainly XML and JSON, but we find still that the XML encoding is the most usable one because of the flexibility and the abstraction features that it provides. Then during the years, we also found that naturally the DATEX II information model is skewed towards load operated data sets, of course, because it's you, the developer, that has done the main work of this. We have though found that in many cases, especially for research, it's possible to reinterpret some of the attributes and interpret the elements in a way that you can still fulfill your use cases, and as long as you provide documentation and explanations for this, it's quite feasible. We look forward to having or being able to influence the DATEX II information model to be more also adaptable for vehicles or the vehicle data set. Profiles, it's a good concept for developing contracts between the different parties. So it's a good use for that. But when you end up implementing this, and at least to our experience, you usually end up using the complete scheme, as I said, because you will want to reuse your DATEX implementation code as much as possible. The tool chain for creating the extensions is a bit of a steep learning curve. It works in the end, but you need to invest quite a bit of time to understand the inner workings of this and also how the tools interact. And as I said before, and want to emphasize once more, is that the website and this community around DATEX is a great asset for us as an OEM to be able to do data exchange in a standardized way.